Hello, in this video I'm going to explain how to solve projectile motion physics problems. A little background, the content objective, I can solve a projectile motion physics problem. Language objective, I can write out my work showing how I solved a projectile motion problem. This video assumes that you have some background. If you haven't watched a video or aren't familiar with how to solve free fall problems, how to resolve vectors, or to solve kinematics problems, I'd recommend you watch those first because you need a lot of that background. Step one, solving projectile motion problems. What you're going to have is some scenario, some problem that you're trying to solve. The scenario that we're going to go through, it says a water balloon is shot from a three-person slingshot moving 28 meters per second at 63 degrees. What is this balloon's maximum range? Solving a projectile motion problem is really a series of problems, the first of which involves vectors. So step one is to draw a picture. And so I drew out a picture of what this scenario sort of looks like. Again, what you know is the velocity and the angle. What you're asked to solve for is what is the total distance that this balloon would travel. The second step you'll have to do is use a little vectors background, a little trigonometry background, and resolve that vector into x and y components. And so you know you have a 28 meter per second velocity of the three-person slingshot, but some of that velocity is in the x direction and some is in the y direction. And so using SOHCAHTOA, sine and cosine functions specifically, what you can do, and I've just shown the work here, you can take a look, pause this if you need to figure it out on your own. You can resolve this 28 meters per second vector into a y component. What's the y velocity? And using the cosine function to figure out what is the x component. And so that's step number two, use trigonometry to resolve your vector into components. What you can do after that is you can define all the known variables that you know in the x direction for like a kinematics type problem, in the y direction, which is sort of a free fall type problem. And so what we know, first in the x direction, we're going to assume that there's no friction, there's no air resistance. And so our acceleration, once the object starts moving in the x direction, it's going to continue at that same speed forever. We don't know the time. We're trying to solve for the displacement. So that's going to be our final answer, that delta x. We resolved that triangle into x and y components, and we figured out that the velocity initial was 12.72 meters per second. And since the object isn't speeding up or slowing down in the x direction, we know that our velocity final is also going to be 12.72 meters per second. And that's not realistic, but that's just assuming no friction, no air resistance. In the y direction, we can assume that the object is in free fall. Again, probably not true, but we're going to assume that it's in free fall. So we have acceleration due to gravity that's negative 9.8 meters per second. Again, we don't know time. We know that the delta y, or the change in vertical position, is going to be 0. If an object flies up into the air and then lands at the same height, the change in position is 0 in the y direction. It goes up, it goes down. But the net movement is 0. We figured out the velocity initial, which is 24.95 meters per second using the trigonometry over here. And if something flies up in the air, is in free fall, and then lands at the same position, y position, then our velocity final should be equal and opposite our velocity initial. After you figured out all your variables, one of the main tricks for solving projectile motion problems is to use your y information, use the information that I'm highlighting here, the acceleration, delta y, if you know what velocity initial, velocity final, to solve for time. And if you can use the y values to solve for time, you know that the time that something is in the air is going to be equal to the time that something is moving horizontally. And then you can solve for your answer. So the more challenging projectile motion problems, the next step, step 4, is going to be use the y components to solve for time. There are 5 different kinematics equations that we use, and the way that you would solve a given problem is you are given 3 pieces of information. We actually know 4. You are solving for a 4th piece of information, and then you are ignoring a 5th piece of information. Since we have 4 pieces of information here, we can just use whichever equation looks easiest. And so I chose to use the one that doesn't use delta y is equal to 0 here, because this equation just looks like it'd be simple to plug numbers into. And so if we have the equation VF equals VI, velocity final, is equal to velocity initial plus acceleration times time, we can plug in our values, follow PEMDAS, and isolate t for time to solve. And we came up with 5.09 seconds. The next thing that we can do is we can plug that information. If that's the amount of time that an object's in the air, moving vertically, that's also the amount of time that an object is in the air moving horizontally. And so we can plug that value into what we know about motion in the horizontal or the x direction. And then we can go back to the drawing board and complete now a kinematics problem. And so we're no longer solving for time, but we can solve for displacement. Again, we have to figure out what do we know, what equation are we going to use. Again, we have 4 pieces of information, and we're solving for a 5th. I figured this equation would be pretty easy to use when solving for, again, delta x is what we're looking for. In this equation, we're not going to use acceleration. Again, plugging into the equation, change in position is equal to 1/2 velocity initial plus velocity final times time. I plugged in those values. And when I did, I came up with a displacement in x direction. How far did an object travel? At 64.74 meters. There are a bunch of different equations that I could have used, a bunch of different ways that I could have done this. But that is the process for solving for a projectile motion problem. To first use a little trigonometry and to resolve some vector into its components. To identify what you know. To then use freefall information to solve for time. And then finally, to plug the values for time that you know into a kinematics and x direction type problem to solve for the variable that you're looking for. Thank you very much. If you have any questions, please feel free to stop on the homework help hours, the virtual science homework help times, or shoot me an email if you have any questions. Thank you very much. Have a great day.